Video, we're going to go over test number 4. So in question number 1, it's asking which statement is not always true. The best thing to do is to draw yourself some pictures. So we have triangle ABC and we have triangle DEF. If we know these two triangles are congruent to each other, then we know the corresponding parts, the corresponding sides, and the corresponding angles should also be congruent. Taking a look at the answer choices, BC, congruent to DF. Already, I see that BC and DF do not correspond. And if we look at the letters in the triangles, BC is the second and third letters. EF is what BC should correspond to, not DF. So answer number 1 is the correct answer. That is a false statement because it doesn't correctly list the corresponding parts of the two congruent triangles. Angle A and angle D do correspond. Congruent triangles have the same side measurements, so they should have the same area and perimeter. When writing a proof, vertical angles alone can justify that angles are congruent to each other. Remember that vertical angles are always congruent no matter what. We are told that AN, says it's congruent to, I put down as parallel to, is congruent to SC. And it says, which additional statement is sufficient to prove the two triangles congruent by AAS? So it's saying just with the givens, which statement can prove the triangles congruent with AAS? Let's take a look at one. AS and NC bisect each other. That means AS is being cut in half, and so is NC. And yeah, that does prove the triangle's congruent, but not by AAS. That's side, side, side. So that's not the choice that we're looking for. K is the midpoint of NC. Well, that tells us NC is being split into two congruent parts. That's all that it tells us. That's not enough information. Even with the vertical angles, that's SSA, or ASS if we read it the other way, which we know is not a valid method of proving triangles congruent. AS is perpendicular to CN. If they're perpendicular, let me get rid of the last example, the last answer choice. There we go. Okay, so if they're perpendicular, that means where they intersect, they form right angles. So that would be here and here, each of the spaces where they intersect. That gives us more information, but just with the given side and now those right angles, that's not enough information to prove the triangle's congruent. That's just one S and one A, not enough. And finally, AN is parallel to SC. Well, if we have parallel lines, we should think about parallel lines cut by a transversal. Notice the letter Z. In the corners of the Z are our congruent alternate interior angles inside the parallel lines on different sides of the transversal. Let me get a different color. Let me highlight the parallel lines again, because I want you to notice that there's also this transversal that intersects them. And notice how we have another Z. It's a backward Z, but it's another Z shape. And in the corner of that letter Z is another pair of congruent alternate interior angles. Remember that alternate interior angles are congruent when lines are parallel, when parallel lines are cut by a transversal. And now, ASA, but if I put in my vertical angles, which are always congruent, now I have AAS. AAS. So answer choice 4, the alternate interior angles along with the given vertical angles proves the triangle's congruent by AAS. The other answer choices don't give you two congruent angles and a congruent side that follows. Okay, AB is congruent to DE. Angle A is congruent to angle D. And angle B is congruent to angle E. Well, that's ASA. Okay. Let me draw my diagrams here. Triangle BAT and triangle CRE. Angle A is congruent to angle R, and BA is congruent to CR. You need to make up one extra piece of information that will make the triangles congruent. Anything goes as long as it proves the triangle's congruent. I'll just say angle T congruent to angle E. That's going to be my statement. And that would give me AAS. Not the only option. Whatever statement you make up, just put down which method it chose. Okay, so we're told that both of these triangles are isosceles, and the key here is that they're congruent to each other. So if these triangles are isosceles, we know that their base angles are congruent, and we know that since the triangles themselves are congruent, the corresponding angles are congruent to each other. So that means the angles in this triangle and the base angles in this triangle are all equal to each other. So we can set up an equation by saying that 5x, one of the angles from this triangle, is equal to 2x plus 18, the corresponding angle to it in this triangle. Some people were trying to set an equation like 5x plus x is equal to 180. It doesn't work because you don't know that this angle is 5 times as large as this one. So we can't just make that up. So I just want to put that out there why that doesn't work. Subtract 2x from both sides. 3x is equal to 18. So we have x is equal to 6. Plugging in to find the measurement of angle B. So angle C is 5 times 6, so that's 30. And then I know this angle is also 30. 30 plus 30 is 60. 180 minus 60 is 120. So angle B is 120 degrees. Then it's asking for BAG, which is this exterior angle of the triangle. Remember, the exterior angle of a triangle is equal to the sum of the two non-adjacent interior angles, which is 150. 120 plus 30 is 150. If you didn't remember the exterior angle theorem for triangles, just know that this angle is supplementary to the one right next to it. 180 minus 30 is that same 150 degrees. Moving down, we know that PR is congruent to PS. RQ is congruent to QS. Angle SRQ is congruent to angle RSQ. And our goal is to prove that angle PRS, so this piece of the angle up here, is congruent to angle PSR, the piece of the angle right up here. So we have a fill in the blank proof, and sometimes that can be easier because it kind of gives us a direction to go in. And sometimes that can make life harder because then we have to try to follow somebody else's pattern of reasoning. But let's do our best to use the hints that are given to us to figure out which way to go to prove the two angles congruent that we're interested in. So I see my first step is the givens. Those are all the givens listed out there in step 1. Now it's asking me about the reflexive postulate. There are a lot of different things I can write down for reflexive postulate because, anything is congruent to itself. So I'm going to look down for a hint so that I know I'm doing a reflexive postulate that's actually going to be helpful to me in this proof. So even if you said something is congruent to itself, you might not have received credit for it if it wasn't helpful to getting somewhere else in the proof. We're trying to first prove that triangle RPQ, so that's this triangle over here, is congruent to triangle SPQ, this triangle over there. I'm going to highlight them. Here's triangle RPQ. And here's triangle SPQ. Now, let's think about what would make sense, what's shared between those two triangles. I see that PQ is the shared side between those two triangles. So I'm going to write down PQ is congruent to itself by the reflexive postulate. And that makes these two triangles congruent by SSS, side, side, side. Now, since we know the two triangles are congruent, we can say that angle PRQ, this whole angle in this yellow triangle, is congruent to angle PSQ, this whole angle in the green triangle. Notice how angle PRQ and angle PSQ are in the same spots in the two different triangles. We call those corresponding angles. And since the triangles are congruent, we do know that the corresponding angles are also congruent by CP, CTC. Corresponding parts of congruent triangles are congruent. Now, which given was missing? The one about the angles. Angle SRQ. So we marked that before in blue. That was this angle right here, the piece of the whole black angle. So angle SRQ congruent to angle RSQ, which was the piece of this whole black angle. I see next we're going to be using subtraction. And that makes sense because our goal is to end up with this top piece of the big angle and this top piece of this big angle. So if we have the big angle and we want to make it smaller to get just the top piece of it, that makes sense that we'd be using subtraction because we're starting with something bigger and we're trying to make it smaller. And it works out great because we know that the two big angles are congruent. And we know that the parts that we want to subtract off are congruent. So we're all set to do our subtraction. We can start with the big black angle on this side. That's angle PRQ. And from angle PRQ, we should be subtracting off angle SRQ, this blue angle, to be left over with the angle that we're interested in. So minus angle SRQ. And let's double check angle PRQ. Take away the blue part, take away angle SRQ. Definitely does leave us over with angle PRS. And that's what our goal was. And that's congruent too. On the other side, the whole big black angle is angle PSQ. And to be left over with angle PSR, which is the angle we're interested in, we have to subtract off this blue angle, angle RSQ. And that leaves us over with angle PSR, the angle that we're actually interested in. Now, how do we justify that this minus this is that, and that this minus this is that? Well, that's by substitution. We're replacing the subtraction with what it actually is. And remember that substitution usually always follows the addition or subtraction postulate as the very next step. For the subtraction postulate step, a lot of you were trying to subtract triangles. You can't subtract triangles from other triangles. Some people were trying to subtract angles from line segments. You can't mix and match line segments and angles. You either subtract angles or you subtract line segments. And then finally, another thing that people were doing is subtracting line segments when the goal was to end up with angles. If you want to end up with angles, if you subtract line segments, then you're pretty much not going to end up with angles because you're subtracting line segments. Moving along, angle NKL is congruent to angle NJM. KL is congruent to JM. And we need to prove that LN is congruent to MN. It is so hard to see what's happening here because we have two overlapping triangles. But I see LN. If I take my highlighter, LN is a side of this triangle here in yellow. And I see that MN is a side of this triangle over here in red. So I'm just going to take those two triangles and I'm going to draw them separately. Terrible artist over here. That's K. That's N. That's L. Let me draw the other triangle facing the other way. That's J. That's N. And that's M. And I'm going to just mark the triangle according to the diagram the way that we marked it here. So I'm just going to transfer our markings here. We marked JM congruent to KL. That was given. And our goal is to prove LN congruent to MM. So we already have an angle and a side just from the givens. And when we have overlapping triangles, we're going to look for something that's shared or in common because they overlap. So there's going to be something that's shared. Now, I'm going to look at the letters and see what's the same. If it's one letter that's the same, then an angle is shared. If it's two letters that's the same, that means a side is shared. And I see that the only thing in common between the two triangles is angle N. And if we take a look at the original diagram, angle N is where the overlap occurs. Angle N is shared between the two triangles. So angle N is congruent to itself by the reflexive property. Then we have angle side to prove the triangle's congruent. And then the very next step, after we know the triangles are congruent, will be to say that LN is congruent to MN by CPCTC. So we can write this out super quickly. Statements, reasons, our givens. I'm not going to write that. Save some time. But from our givens, this side and this angle was given. Then we just need to mention the shared angle that we were using for AAS. And that's by the reflexive postulate. And that's enough information to say triangle JNM is congruent to triangle KNL. Once again, that's by AAS. And then finally, we can say that LN is congruent to MN by CPCTC. In the next one, we are told that HJ is congruent to JK. In a triangle, when there's two equal sides, the angles opposite those sides are congruent. So these two angles are congruent. To figure out what they are, I know all three angles in a triangle make 180, and this one's already 70. So 180 minus 70 gives me 110. So together, these need to be 110. And since these are both the same, I'm going to divide by 2, and I get 55 degrees for this one and for this one. Now I know that this angle and this angle are supplementary. They add to 180 degrees. So if I go to my calculator, 180 minus 55 is 125. Now, I know two angles in this triangle, the 125 and the 28. I can add them together. I get 153. And then I can subtract that from 180 to find the last angle, which is 27. So we do need to answer the question. Triangle GHK, that's this triangle here on the left, is not isosceles. It did not ask for an explanation. It just said to justify your answer. So just having calculations is enough to justify. It didn't say explain. It's not isosceles because it doesn't have any equal angles. And if it has no equal angles, that means it has no equal sides. And finally, over here, we need to prove that triangle ABC is not congruent to triangle RST. So as long as we can show that one pair of corresponding sides is not congruent, that's enough. Proving something is true is harder because we have to prove that it's true in every single situation. So to prove that triangles are congruent, we would have to show that all of the corresponding sides are in fact congruent. But if you're proving something's not true, as long as you can find one counterexample, that's enough to disprove it. So if I can find one pair of corresponding sides that's not congruent, that would disprove that they're congruent. So the formula is the distance formula because we're finding side lengths. So that's x2 minus x1 squared plus y2 minus y1 squared. Okay, well, I'm going to start with AB, and AB corresponds to RS. So I want to see if they are congruent. So I want to see the coordinates as well. Plugging in AB, x2 minus x1 plus y2 minus y1. That is 3 squared plus negative 8 squared. So that's 9 plus 64. And that gives me radical 73. Okay? AB, the first two letters of this triangle name, corresponds to the first two letters of this triangle name. Triangles are named with their corresponding parts in order. So AB corresponds to RS. Those are the two sides in the same spot. So I'm going to now find the length of RS, and I'm going to see if it's the same. So let me plug into my distance formula. 5 minus negative 2 squared plus 6 minus 9 squared. So that's 7 squared plus negative 3 squared. So that's 49 plus 9. And that gives me radical 58. So these corresponding sides are clearly not the same length. So I'm going to go to my concluding statement, and I'm going to answer the question. The triangles are not congruent because corresponding sides AB and RS are not congruent.